Hello, and I welcome you all to Scientific Study for You. I am Apuru Pathak, and after watching this video, you will be able to write the electronic configuration of any elements from the periodic table in the KLMN format, except few exceptions, guaranteed. This is going to be a detailed video, and I will show you the electronic configuration of first 30 elements. I will also solve 11 problems to make your understanding crystal clear on this topic. So this video will be long. The people having lack of patience, I will highly recommend to quit already this video. Okay, congratulations. So you are the few patient students interested in learning this strategy. So without any more delay, let's get started. So there are 4 rules in writing the electronic configuration of elements. The rule 1 is the electrons will be filled in the shells in order of increasing energy, that is KLMN. Which means that K shell will be filled first, then L shell, and so on. Okay. The second rule is the maximum number of electrons in a shell is given by max electrons equal to 2n square, where n is the principal quantum number. Okay. If K shell where n is equal to 1, then max electrons equal to 2n square equal to 2. In L shell, when n is equal to 2, max electrons will be 2n square equal to 2 into 2 square equal to 8. In M shell, where n is equal to 3, max electrons will be 2n square equal to 18 electrons. In N shell, n is equal to 4, so max electrons will be 2n square equal to 2 into 3 square equal to 32 electrons. The third rule is the octet rule. It says that the nth cell or the outermost shell getting filled cannot have more than 8 electrons. Okay, this rule I will explain better with the help of example when I will be showing the electronic configuration. So don't worry about it. Okay, the fourth rule is the n minus 2 rule. Okay, this is a very exclusive rule made by me. It says that the number of electrons in the nth shell or the outermost shell can exceed 2 only if the n minus 2th shell either doesn't exist or fully filled or have 32 electrons, and n minus 1th shell is either fully filled or have 18 electrons. I will explain it, don't worry. And here is a note. The electrons will be filled first in the n minus 2th cell and then in the n minus 1th shell. Okay, so the electron will be filled in the first n minus 2th shell, then in the n minus 1th shell. Okay, so try to see this diagram and understand it. This is the nucleus, these are the shells from the nucleus, this is the K shell, L shell, M shell, and suppose this is the nth shell. Okay, this is the n minus 1th shell and this is the n minus 2th cell. Then rule 4 says that the number of electrons in the nth cell can exceed 2 only if the n minus 2th shell either doesn't exist or fully filled or have 32 electrons. Okay, and the n minus 1st shell is either fully filled or have 18 electrons. So if both these conditions will be true, then only there can be more than 2 electrons in the last nth shell. Okay, this is the rule 4, and it will be more clear when I will be telling the electronic configurations. Don't worry once again. Okay, so there are few exceptions to this rule which I have made for writing the electronic configuration. So I will tell you this. Okay, the exceptions are chromium, copper, okay, Nb, Mo, Ru, Rh, Pd, Ag, La, Gd, Pt, Au, Ae, Th, Pa, U, Np, Cm, and Rg. Except these elements, you can write electronic configuration of any elements in the periodic table. Just pick up any element and start writing the electronic configuration using these rules. It will be successful. Okay, so let's see the electronic configuration of first 30 elements, then you will understand better that how to write it. Okay, let's start. So this is the atomic number here. This is the element. Okay, this is the K shell, this is the L shell, this is the M shell. Okay, this is the K shell, this is the L shell, this is the M shell, this is the N shell, this is the O shell, and the P shell. And according to 2n square rule, 2 electrons in K shell, 8 electrons in L shell, 18 electrons in M shell, 32 electrons in N shell, 50 electrons in O shell, and 72 electrons in the P shell. Okay, these are the maximum capacities. So let's start from the hydrogen. Hydrogen is having 1 electron. Okay, so 1 electron will go in the K shell first, which was the first rule, that the order in which electron will be filled is the K first, then L, then M, then N, and so on. Okay, so 1 electron in the K shell, no problem. In case of helium, 2 electrons in the K shell. no problem again. In case of lithium, since K shell is fully filled, now the electron will go to the L shell, one electron in the L shell, okay, no problem. In case of beryllium, 2 electrons in the K shell and 2 electrons in the L shell. Now check carefully. When 2 electrons in the outermost shell, then it will check, if suppose it is the nth shell, then it will check if n minus 2 shell either doesn't exist or have fully filled electrons or having 32 electrons. In this case, there is no n minus 2th shell, so it doesn't exist. So first condition is true. Second condition should be n minus 1th shell must be fully filled or having 18 electrons. So in this case, it's fully filled. K shell is fully filled having 2 electrons. That's why now we can go after 2 electrons in the nth shell. So in case of boron, we will see that 2 electrons in the K shell and 3 electrons in the L shell. We exceeded 2 electrons because the other two conditions were valid of rule 4. Okay. Now in case of carbon, 2 here, 4 here. In case of nitrogen, 2 here, 5 here. In case of oxygen, 2 here, 6 here. In case of fluorine, 2 here, 7 here. In case of neon, 2 here and 8 here. Now see here, okay, this is having 8 electrons in the nth shell. Now according to the octet rule, which was the third rule, it cannot have more than 8 electrons in the outermost shell. That's why the electron will be shifted to the next shell in the next element, okay, which is the M shell. So in case of sodium, you will see that 2 electrons in the K shell, 8 electrons in the L shell and 1 electron in the M shell, okay. In case of magnesium, again 2 here, 8 here and 2 electrons here. Now again it will check if the n minus 2 electrons, if the n minus 2 shell is either doesn't exist or fully filled or have 32 electrons. In this case, it's fully filled. So first condition is valid. Now n minus 1 shell, it should be either fully filled or having 18 electrons. It is fully filled. So again, this condition is also valid. That's why we can exceed now from 2 in the nth shell. That's why in aluminium, 2 electrons here, 8 electrons in the L shell and 3 electrons in the M shell. We exceeded 2 already, okay. In case of silicon, 2 here, 8 here and 4 here. In case of phosphorus, okay, in case of phosphorus, 2 here, 8 here and 5 here. In case of sulfur, 2 here, 8 here and 6 here. In case of chlorine, 2 here, 8 here, 7 here. In case of argon, 2 here, 8 here and 8 here. Again, octet rule will come in picture, which means that the outermost shell cannot have more than 8 electrons. That's why the next electron in the next element will move to the next shell, which is the N shell, okay. That's why in case of potassium, 2 here, 8 here, 8 in the M shell and 1 electron will be in the N shell. And in case of calcium, 2 electrons in the K shell, 8 electrons in the L shell, 8 electrons in the M shell and 2 electrons in the N shell. Again it will check according to the fourth rule that if n minus 2 electron shell is either fully filled or doesn't exist or have 82 electrons. In this case, it's fully filled, so no problem. Now we will check for the n minus 1 shell. It's having 8 electrons, so it's neither fully filled nor it's having 18 electrons. That's why the next electrons will go in the n minus 1 M shell, okay, up to 18 electrons. Then only it will exceed from 2 in the N shell, okay, according to the fourth rule. So in case of scandium, we will see that 2 electrons here, 8 electrons in the here and the next electron will enter this shell, M shell, because the n minus 1st shell should be having 18 electrons. Then only this electron can exceed 2, okay. So 9 electrons here. In case of titanium, 2 here, 8 here and 10 here and it will remain 2. It's waiting for the n minus 1st shell getting filled up to 18, then only it can exceed 2, okay. In case of vanadium, 2 here, 8 here, 11 here, 2 here. Chromium is the exception, okay. In case of chromium, 1 N shell electron will be shifted in the M shell, okay. That's why it's the exception. So 2 here, 8 here, 13 here, it would be 12 here, but because 1 electron got shifted from the N shell to the M shell, that's why it's having 13 electrons and 1 electron in the N shell. Now next, manganese is the regular element. So 2 here, 8 here, 13 here and 2 here, okay. In case of iron, 2 here, 8 here, 14 here and 2 here, okay. In case of cobalt, 2 here, 8 here, 15 here and 2 here. In case of nickel, 2 here, 8 here, 16 here and 2 here, okay. Actually the last shell is still waiting for the n minus 1 shell to have 18 electrons, because the n minus 2 shell is completely filled, no problem here. First condition is valid, but the second condition for the n minus 1 shell, it's not having 18 electrons or fully filled. That's why it's waiting still, the nth shell, okay. So the next we will see for the copper is the exception again. Okay, copper is the exception again. In copper, the nth, like in the n shell, one electron gets shifted in the m shell, similar to the chromium. That's why 2 here, 8 here, okay, 18 here, and 1 electron here. In case of zinc, it's a regular element again, 2 here, 8 here, 18 here, and 2 here. Now you can see that both the conditions of the fourth rule are valid, because the n minus 2 shell is completely filled and n minus 1 shell is completely filled, as well as it's having 18 electrons. Okay, that's why now we can exceed 2 electrons in the nth shell. Okay, so that's why in case of gallium you will see that 2 here, 8 here, 18 here, and 3 electrons in the nth shell according to the fourth rule. Okay, I think it should be clear, but I will solve 11 problems, okay, to make your understanding crystal clear on this. So just stay tuned. Okay, let's see how to do this. Okay, again, this is the atomic number 8. Okay, we will write the electronic configuration for atomic number 8 and try to observe how I approach the electronic configuration. Okay, the same way you will follow. Okay, so first 2 electrons will be filled in the K shell. Okay, after that in the L shell we will fill 2 electrons, and I will check if the n minus 2 shell is completely filled or doesn't exist, or having 32 electrons. In this case it doesn't exist, so no problem. In the n minus 1 shell we will check the same condition, that if it's fully filled or having 18 electrons. In this case it's fully filled, so no problem. That's why we can go up after 2 here. Okay, we can exceed 2 here, so we need 6 more electrons, so we will go up to 6 here. Okay, so 2, 6, 8. So the final electronic configuration will be 2 here and 6 here. Okay, now in the next, in case of atomic number 18, okay, again we will fill 2 electrons here. After that we will go 2 here, and we will check if n minus 2 doesn't exist, or have fully filled orbital shell, or have 32 electrons. Okay, in this case it doesn't exist, so first condition is valid. And the n minus shell we will check if it is fully filled or having 18 electrons. In this case it's fully filled, so it's again okay, so we can exceed 2 electrons in the nth shell here. Okay, so we will go up to 8 here, and the octet rule will come in picture, and it will say that no more electrons than 8 can be filled in the outermost shell. That's why the next electron will go to the next shell. Okay, so 2 electrons will be here. Again it will be checked that n minus 2 shell either doesn't exist, or fully filled, or having 32 electrons. In this case it's fully filled, so fine, no problem. The n minus 1 shell, it will check either it is fully filled or having 18 electrons. So in this case it's fully filled, so fine again. That's why we can exceed 2 here. 10 electrons already done. We need 8 more electrons, so we will go up to 8 here. Okay, that's why we will see 2, 8, 10, 8, 18. So the electronic configuration will be 2 here, 8 here, and 8 in the M shell. Okay, in the next, it is 28 atomic number. You will see again 2 electrons will be filled here. After that, here we will fill 2 electrons, and we will check if the n minus 2 shell either doesn't exist, or fully filled, or having 32 electrons. In this case it doesn't exist, so it's okay. The next n minus 1 shell we will check if it is fully filled or having 18 electrons. In this case it's fully filled, so it's okay again. So we can exceed 2 in the nth shell according to the rule 4, no problem. So we will go up to 8, and after that the octet rule will come in picture, and it will say that you cannot have more than 8 electrons in the last shell. That's why you will have to go to the next shell. That's why we will go here, and again we will fill 2, and we will check if n minus 2 is fully filled or having 32 electrons or doesn't exist. In this case it's fully filled, so no problem. We will check if n minus 1 is fully filled or having 18 electrons. In this case it is fully filled, so no problem again. So we can exceed 2, so we will fill electrons up to 8 here, and again the octet rule will come in picture. It will say that no more than 8 electrons can be filled in the outermost shell. That's why again the electrons will be shifted to the next shell. Okay, so let's count first. 2, 8, 10, 8, 18. Okay, so 8 to 10 and 18, so we need 10 more electrons. So 2 electrons will be shifted here, and I will again check if the n minus 2 shell is completely filled or having 32 electrons. It is completely filled, so no problem. Then we will check for n minus 1 shell, is it completely filled or having 18 electrons? In this case it's neither fully filled nor having 18 electrons, so the next electrons will be filled in this shell only. Okay, so we need 10 more electrons, 8 electrons already here, so 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so 10 electrons will be filled here up to 18, and the total number of electrons will be 8 to 10, 28, oh sorry, 16 will be filled here, then it will be 16, 10, 16, 10, 26 and 2, 28. Okay, so the final electronic configuration will be 2 here, 8 here, 16 here and 2 here. Okay, same rule, follow the same rules. Okay, in the next problem again we will see it's atomic number 38. Next problem is the atomic number 38. Okay, again we will fill 2 electrons here. After that we will go to L shell, and here 2 electrons, and we will check if n minus 2 doesn't exist or have fully filled orbital, fully filled shell, or it's having 32 electrons. In this case doesn't exist, so that's okay. We will check for n minus 1 shell. We will see that it's fully filled, so it's okay as well. That's why we can go up to 8 here, and the octet rule will come in picture. It will say that we will have to shift to the next shell, so we will go here. We will fill 2 electrons. Again we will check if n minus 2 shell is fully filled or having 32 electrons. It's fully filled, so no problem. We will check for n minus 1 shell, if is it fully filled or having 18 electrons. It's fully filled, so no problem. So again we will go up to 8 here, and the octet rule again will come in picture, and we will shift to the next shell. We will put 2 electrons here. Again we will see if n minus 2 shell is fully filled or having 32 electrons. It's fully filled, so no problem. We will check for n minus 1 shell if it is fully filled or having 18 electrons. It's neither fully filled nor having 18 electrons, so we will put the electrons here. It's having 8 electrons at the moment. We will go up to 18 electrons, then there will we will go up to 18 electrons here, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. Then total number of electrons will be 18, 10, 28 to 30. Okay, 30 electrons. So now we can exceed here, since both the conditions are valid for rule 4. Now we can go from 2 to 3. Okay, 3, 4, 5, 6, 7 and 8. Now we can count again. So there will be 18, 10, 28, 8, 36 electrons. Again octet rule will come in picture, so we will go to the next shell and put 2 electrons. Again we will add 2, 8, 10, 18, 28, 8, 36 to 38. So that will be the electronic configuration: 2, 8, 18, 8 and 2. Okay, so the next atomic number is 48. Okay, in case of 48, again 2 we will fill here. After that 2 we will fill here, and we will check if n minus 2 doesn't exist. Yes, it doesn't exist. Then we will check for n minus 1 if it's fully filled or having 18 electrons. It's fully filled, so no problem. We will go up to 8. The octet rule will come in picture. Again we will go to the next shell. Again we will check if n minus 2 doesn't exist or n minus 2 is fully filled or having 18 electrons. It's fully filled, so no problem. Again we will check for n minus 1 if it is fully filled or having 18 electrons. In this case it is fully filled, so no problem. So we will again go up to 8 here. Octet rule will come in picture, and it will say it cannot have more than 8 electrons in the last shell. That's why then the electron will again shift it to the next shell. Okay, again we will check after putting 2 electrons that n minus 2th shell either fully filled or having 32 electrons. It's fully filled, so no problem. The n minus 1st shell, is it fully filled or having 18 electrons? It's neither fully filled nor having 18 electrons, so the next electrons will be filled in the n minus 1st shell up to 18, 19, 11, 12, 13, 14, 15, 16, 17 and 18. Okay, after that we can now exceed 2 in the nth shell, and we will exceed up to 8 here. Okay, and again we will add 2, 8, 10, 28, 8, 36. Okay, so again octet rule here come in picture, and we will again go to the next shell. After 2 we will check if n minus 2 shell is fully filled or having 32 electrons. In this case it's fully filled, so no problem. We will go to n minus 1 shell. Is it fully filled or having 18 electrons? It's neither fully filled nor having 18 electrons, so we will fill the electrons here next. So how many electrons left? Let's check. 8, 2, 8, 10, 28, 8, 36 to 38. 10 more electrons. Okay, so we will go here. 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. Okay, so we will fill up to 18 here, and let's add 8 to 10, 8, 28, Basically 18 to the 36 and 10 46 to 48. So that's it. Total number of electrons completed. So electronic configuration will be 2, 8, 18, 18 and 2. Okay. In case of atomic number 58, again 2 electrons will be here. After that 2 electrons will be filled here, and we will check for n minus 2 if it doesn't exist or fully filled, or 32 electrons. In this case it doesn't exist, so no problem. Then we will check for n minus 1 shell. Is it fully filled or having 18 electrons? Is fully filled, so no problem. We will go up to 8 here. Again octet rule will come in picture, and it will say it cannot have more than 8 electrons, so it will be shifted to the next shell. So 2 electrons here. Again we will check if n minus 2 shell is fully filled or having 32 electrons. In this case it is fully filled, so no problem. Then we will check for n minus 1 shell. Is it fully filled or having 18 electrons? It's fully filled, no problems. Again we will go up to 8 here. Then octet rule will come in picture, and the electron will be shifted to the next shell. Again 1 electron and 2 electron we will fill here. Again we will check if n minus 2 is having 32 electrons or fully filled. In this case it's fully filled, no problem. We will check for n minus 1 if it is fully filled or having 18 electrons. It's neither fully filled or nor it's having 18 electrons, so we will fill up to 18 here. Okay, and again after that we can exceed 2 here in the nth shell according to rule 4, so we will go up to 8 here. Okay, and again the octet rule will come in picture, so we will put 2 electrons here, and we will again check if n minus 2 shell is fully filled or having 32 electrons. In this case it's fully filled, so no problem. Then we will check for n minus 1. Is it having 18 electrons or fully filled? It's neither having 18 electrons nor fully filled. Okay, so again we will fill up to 18 here. Okay, now we can exceed 2, but before exceeding let's count how many electrons we have already filled. 2 electrons here, 8 electrons here, so 18 36, 10 46, 48, 10 more needed. Okay, so we will exceed up to 8 here. We will fill up to 8. Again octet rule will come in picture, and it will say no more than 8 electrons can be accommodated in the last shell. So again electrons will be shifted to the next shell. Let's say 2 here. Again we will count 40. It was 36, 10 46, 8 54, 2 56. So 2 more electrons are left. Again after 2 we will check if n minus 2 is fully filled. No, it's not fully filled. Neither it's having 32 electrons, so the electrons will be filled in this shell, the n minus 2 shell. Okay, so we need 2 more electrons, that's why it will be 20. Okay, we will fill it up to 20. Okay, so let's count the total number of electrons once again. 18, 28, 28 and 48, 8 56, 258. Okay, so the electronic configuration will be 2, 8, 18, 20, 8 and 2. Okay, in the next example it's 68. Okay, in this case again 2 will be filled here. After that 2 will be filled here, and we will check if n minus 2 doesn't exist. Yes, it doesn't exist. Then we will check if n minus 1 having fully filled or 18 electrons is fully filled, no problem. We will go up to 8 here, and the octet rule will come in picture. Again we will go to the next cell. We will put 2 here. Okay, and after that again we will check if n minus 2 is fully filled or having 32 electrons or doesn't exist. It's fully filled, no problem. We will check for n minus 1 if it is fully filled or having 18 electrons. It's fully filled, no problem. Again we will go up to 8 here. Again octet rule will come in picture, and it will say go to the next shell. We will fill 2 electrons here. After that again we will check if n minus 2 doesn't exist or having fully filled or having 32 electrons. It's fully filled, so no problem. We will check for n minus 1 if it is fully filled or having 18 electrons. It's neither fully filled nor having 18 electrons, that's why we will fill up to 18 here. Okay, now we can exceed 2 here, and we will go up to 8 here. Okay, now octet rule will again come in picture, and we'll fill 2 electrons in the next shell. After that we will check if the n minus 2 is fully filled or having 32 electrons. It's fully filled, so no problem. After that we will check for n minus 1 if it is fully filled or having 18 electrons. Okay, so n minus 1 neither fully filled nor having 18 electrons, so we will fill up to 18 here. After that we can exceed 2 here, so we will go up to 8, and again octet rule will come in picture, and it will say go to the next shell. That's why we will fill 2 electrons in the next shell. And let's count first. So 36, 10 46. Okay, 36, 10 46, 8 54, 2 56. Okay, So we will check again if n-2 shell is fully filled or having 32 electrons. It's neither fully filled nor having 32 electrons. That's why we will fill again electrons in the n-2 shell. How many electrons we needed? How many electrons we need to fill? We were having 36, 46, 54, 56. So we need 12 more electrons. Okay, 56, 10, 66 to 68, 12 more electrons. So 12 more electrons will be filled here. Okay, so 18, 12, how much? 18, 12, 20, 30. So it will be filled up to 30 here. Okay, so the final electronic and let's add first. Okay, so 8 to 10, 18, 28, 28, 30, 58, 8, 66 to 68. So final electronic configuration will be 2 here, 8 here, 18 here, 30 here, 8 here, and 2 here. Okay, so in the next example it's 72, it's 77. Okay, again 2 electrons will be filled here. After that next 2 electrons will be filled here, and we will check when n-2 doesn't exist or fully filled or having 32 electrons. In this case it doesn't exist, so we will check for n-1 if it is fully filled or having 18 electrons. In this case it is fully filled, so no problem. We can exceed 2 easily here. We will go up to 8 and octet rule will come in picture, and it will say no more than 8 electrons can be accommodated in the nth shell. That's why the electron will be shifted to the next shell. We will fill up to 2. Again we will check if n-2 doesn't exist or fully filled or having 32 electrons. In this case it's fully filled, so no problem. We will check for n-1 if it is fully filled or it's having 18 electrons. So again this case it's fully filled, no problem. We will again go up to 8 here. After that octet rule will come in picture, and we will go to the next shell, and again we will check for n-2th shell. In this case it's fully filled, so no problem. Again we will check for n-1 shell. It's neither fully filled nor having 18 electrons. That's why we will fill up to 18 here, and after that we can exceed 2 here, so we will go up to 8, and again octet rule will come in picture, and it will say that we will have to move to the next shell. That's why we will fill 2 here. Again we will check n-2, it's fully filled, no problem. We will check n-1, it's neither fully filled nor having 18 electrons, so we will fill up to 18 electrons here. Now we can exceed 2 here, so we will go up to 8. Again octet rule will come in picture. Okay, so again octet rule will come in picture, so we will fill 2 here. Okay, and we will count first. So it's 18, 18, 36, 10, 46, 8, 54 to 56. Okay, so 56, so we need how much more electrons? 56, 662, 662 and 72, so 16 more electrons. Okay, so we will check if n-2 is fully filled or having 32 electrons. It's not fully filled, so next electrons will go to n-2. So if we will fill 16 electrons here, it will be 34 electrons. It will exceed 32, so we cannot do this. Okay, that's why we will fill 14 electrons here only, up to 32, because n-2 rule says it can accommodate maximum of 32 electrons. Okay, so we will fill up to 32, and when this is 32 complete, next the electrons will be filled in the n-1 shell, and it can go up to 18 electrons. Okay, so 2 electrons more needed, so it will go up to 8, 9 and 10. Now we can add 2 here, 8 here, 18, 10, 28, 28, 32 is 60, 70. Okay, wait a second, it's 10, 18, 10, 28, 28, 32, 60, 70. Okay, and 72. Oh, it's not done actually. Here after 32, okay, I mean here more electrons is needed. It's just at the moment it's just 72. Okay, let's add once again 10, 18, 10, 28, 60, 70, 72. 5 more electrons are needed. So here it will go up to, actually it will go up to 15. Okay, now let's add. It will not go up to 10. Actually I misread here. I thought it's 72, it's 77, so it will go up to 15, not 10. Okay, so the final electrons will be 2 here, 8 here, 18, it's 60, 18, 10, 28, 32, 60. Okay, 60, 70, 75 to 77. So the final electronic configuration will be 2, 8, 18, 32, okay, 15 and 2. Okay, again we will see the next example. Okay, we will see the next example. In this case, it's the atomic number is 87. Okay, so again 2 electrons will be filled here. After 2 electrons will be filled here, and we will check if n minus 2 doesn't exist or n minus 2 is fully filled or having 32 electrons. In this case, it doesn't exist, so we will check for n minus 1. N minus 1 is fully filled, so no problem. We will go up to 8 here. The octet rule will come in picture. Then we'll go to the next shell, again check if n minus 2 is fully filled. Yes, it is. N minus 1 is also fully filled, so no problem. We can exceed 2 here. We'll go up to 8 again. After that, again octet rule will come in picture, so we'll go to the next shell. Then again we will check if n minus 2 is fully filled or 32 electrons. Okay, it's fully filled, no problem. Here n minus 1 is neither fully filled nor having 18 electrons, that's why we'll go up to 18 here. And after that we can exceed 2 here, and we'll go up to 8, and again octet rule will come in picture, so we will go to the next shell, and we will again check if n minus 2 is fully filled. Yes, it is. We will check for n minus 1 if it is fully filled or having 18 electrons. In this case, it's neither fully filled nor having 18 electrons, so we will go up to 18 here. Then we can exceed 2 here and go up to 8 here. Okay, again octet rule will come in picture, so we'll go to the next shell and fill 2 electrons. Then again we will check if n minus 2 is fully filled or having 18 electrons. So it's not, so we will fill up to 32 here. Okay, and we will check for n minus 1 if it's fully filled or having 18 electrons. No, it's not having. That's why we will fill next electrons in this case here. But let's count first how many electrons are done. 2, 8, 10, 28, 60, 68, 70. Okay, so we need more 17 electrons. Okay, so the next electrons will be filled here. Okay, in the n minus 1 n up to 18, it will go up to 18 here. Okay, and it will go up to 18 here, and 7 more electrons need to be filled. So in this case we will go up to 8 here. Okay, we will go up to 8 here. Again octet rule will come in picture. Okay, and again we will be shifted to the next shell. So 1 electron here. Let's count how many happen. 2 here, 8 here, 28, 32, it's 60, 70, 78, 8, 86, and 1, 87. So it's done. So the final electronic configuration will be 2 here, 8 here, 18 here, 32 here, 18 here, 8 here, and 1 here. Okay, in the next example, it's atomic number 98. Okay, in this case again 2 will be filled here. After that 2 will be filled here. We will check for n minus 2. In this case doesn't exist, so no problem. We will check for n minus 1. In this case it's fully filled, so no problem. We will go up to 8. The octet rule will come in picture. Again we will go to the next shell. Again we will check for n minus 2. In this case it's fully filled, no problem. Then we will check for n minus 1. It's fully filled, so no problem. Picture. Again we will go to the next shell. Again we will check n minus 2 is fully filled, no problem. Then we will check for n minus 1. It's neither fully filled nor having 18 electrons, so we will go up to 18 here. Then we can exceed 2 here, and we'll go up to 8. After that octet rule will come in picture. Again we will go to the next shell. Again we will check for n minus 2. N minus 2 is fully filled, so no problem. We will check for n minus 1. It's neither fully filled nor having 18 electrons, that's why we will fill up to 18 here. Again we will exceed 2 here, and we'll go up to 8. Again octet rule will come in picture, that's why we will fill 2 here. After that we will see if n minus 2 is fully filled having 32 electrons. It's neither fully filled nor having 32 electrons, so we will go up to 32 here. After that we will fill the rest electron. We will check for n minus 1 if it's having 18 electrons or fully filled. So it's neither fully filled nor having 18 electrons, so we will fill up to 18 here. Let's count how many electrons happened. Okay, 2, 8, 10, 18, 28, 32, 60, 70, 78. Okay, 78 and 2, 80. So we can go. Okay, so we can exceed 2 here, and we will go up to 8 here. After that octet rule will come in picture. Okay, so we will fill the next 2 electrons here, and again we will check. But before checking, let's add 8 to 10, 18, 28, 32, 60, 70, 78, 86 to 88. Okay, so 10 more electrons are needed. We will check if n minus 2 is fully filled or having 32 electrons. No, in this case is having only 18 electrons, so the next 10 electrons will be filled here up to 28. Okay, let's add 8 to 10 and 18, 28, 60, 60, 20, 80, 88, 96 to 98. So it's done. So the final electronic configuration will be 2, 8, 18, 32, 28, 8 and 2. Okay. Now it is the last example, 108 atomic number. Let's see again. 2 will be filled here. After that 2 will be filled here, and we will check if n-2 doesn't exist or fully filled or having 32 electrons. In this case it doesn't exist, so no problem. We will check for n-1 if it's fully filled or 18 electrons. It's fully filled, that's why we will go up to 8. We can exceed 2 here. Okay, we will go up to 8. Again octet rule will come in picture. We will go to the next shell and we will check for n-2. It's fully filled, no problem. Then we will check for n-1. It's fully filled, no problem. Then we will go up to 8 here. Again we can exceed 2. Again octet rule will come in picture. Again we will move to the next shell. Again we will check for n-2. It's fully filled, no problem. Then we will check for n-1. It's neither fully filled nor having 18 electrons, that's why we will go up to 18 here. Then we can exceed 2 here. We will go up to 8, and again octet rule will come in picture. Then we will go to the next shell. Then we will again check for n-2. It's fully filled, no problem. We will check for n-1. It's neither fully filled nor having 18 electrons, that's why we will go up to 18 electrons here. Then we can exceed 2 here, and we will go up to 8. Again octet rule will come in picture, so we will fill 2 electrons here. Next shell. Then again we will check if n-2 is fully filled or having 32 electrons. Okay, so we will fill up to 32 here because it was having 18 only. Then we will check for n-1 if it is fully filled or having 18 electrons. It's neither fully filled nor having 18 electrons, so we will fill up to 18 here. Okay, then we can exceed 2 here, so we will go up to 8 here. Okay, again octet rule will come in picture, so we'll go to the next cell and we will fill 2 here. Okay, and we will count how many electrons happened, then we will check. Okay, so 2, 8, 10, 28, 32, 60, 60, 70, 78. Okay, 86 to 88. Okay, so 20 more electrons needed. So again we will check if n-2 is fully filled. No, it's not fully filled, neither it's having 32 electrons, so we can add electron here next. Okay, so we need 20 more electrons. If we will add 20 here, it will be 38, which will exceed 32, which violates the n-2 rule. That's why we will fill up to 30 here, 32 here only. Okay, basically we will fill how many electrons? 18 to 20, sorry, 18 for 32 and 10. 18 for 22 and 10, 32. So 14 electrons we will fill here. Okay, and it's now having 32 electrons, and the rest 6 electrons it will be filled in the n-1 shell, because the n-1 shell is neither having 18 electrons nor fully filled. So next it will be filled, and the rest 6 electrons will be filled here up to 14. Okay, now let's add 2, 8, 10, 18, 28, 32 it will be 60, 90, 92, 4, 96, 10, 106 and 2, 108. Okay, so the final electronic configuration will be 2 here, 8 here, 18 here, 32 here, 32 here, 14 here and 2 here. Okay, now there's a question. I will leave this question for you. You solve this question. The question is, write the electronic configuration of Z equal to 118, and you can write the solution in the comment section. I will see, I will check, and I will give you the hearts if you will paste the right answer. Okay, so you will solve this question on yourself. It is to check your understanding, you understood well or not the concept. Okay, so I would like to conclude this video. In this video we have learned how to write the electronic configuration of elements, and we saw that there were 4 rules. The first rule was the shells will be filled in order of increasing energy, that is from K, L, M and so on. The next rule was the maximum number of electrons in a shell is given by max electrons equal to 2n square, where n is the principal quantum number. The third rule was the octet rule, which says that in the outermost shell the number of electron cannot exceed 8. Okay, and the fourth rule was the n-2 rule, which said that in the nth cell the number of electron can exceed 2 only if the n-2 shell is either doesn't exist or fully filled or having 32 electrons, and the n-1 shell is either fully filled or having 18 electrons. If both the conditions were valid, then the n-2 rule was valid, and then we can exceed 2 electrons in the n shell. Okay, So that's it. Thanks for watching.